Welcome to our lesson on orchestrating AI platforms with Docker Compose. In today's fast-paced tech world, building robust AI applications often means combining many different services, a front-end, a back-end, databases, caching layers, and more. Managing these individually can quickly become a complex challenge. That's where orchestration tools like Docker Compose come in, simplifying how we develop and deploy multi-service applications. By the end of this lesson, you will be able to understand the fundamental need for multi-service orchestration, effectively configure Docker Compose for your own AI applications, implement crucial patterns like data persistence and service discovery, and apply production-ready strategies to build more resilient systems. Let's dive in and learn how to conduct your distributed system orchestral with confidence. Imagine a major social network or a global ride-sharing platform. They don't run as a single monolithic application. Instead, they operate as thousands of microservices, each handling a specific task like user authentication, content delivery, or payment processing. Without a system to coordinate these services, managing them would be an absolute nightmare of manual starts, stops, and endless configuration files. This is precisely why orchestration tools are vital. Docker Compose gives us this power at a manageable scale, allowing us to define and run a multi-service application as a single unit. It saves us from the constant headache of individual service management, making development and small-scale production much more efficient. It's the key to handling the complex data flows that are typical in modern AI platforms, ensuring everything works in harmony. At its core, a Docker Compose setup creates a unified application stack where each service runs in its own isolated container but communicates seamlessly. This is achieved through several key layers. First, the service layer defines each component, like your front-end, back-end, or database, as independent containers. Then, the network layer sets up an internal Docker network, allowing these services to talk to each other using simple service names instead of hard-coding IP addresses. The volume layer is critical for data persistence, ensuring your database data and application logs survive container restarts. Finally, the configuration layer handles environment variables and secrets, keeping sensitive information secure and out of your code. This layered approach is the foundation for scalable and maintainable AI applications. Let's trace a typical data flow through our AI quiz platform to understand how these services interact. When a student takes a quiz, the front end initiates user interaction, sending their input to the backend. The backend then coordinates the request. It first checks a Redis cache for existing questions. If there's a cache miss, it calls an external AI API for new questions, like the Gemini API. The backend then stores the results in PostgreSQL and updates the Redis cache for future requests. Throughout this process, each service maintains its own state. Redis handles ephemeral cache state, providing quick access to frequently requested data, while PostgreSQL manages persistent quiz data, ensuring long-term storage and integrity. This orchestrated dance of data ensures a smooth and efficient user experience. Real-world systems demand more than just functional services. They need to be robust and secure. Docker Compose helps us implement essential production-ready patterns. This includes health checks and service dependencies, ensuring that, for instance, your database is fully up and running before your backend attempts to connect to it. We also establish isolated networking for secure communication, creating a private network where services can communicate without exposing themselves directly to the outside world. For data integrity, we use persistent volumes. This means your valuable quiz data, user uploads, and application logs will survive even if containers are stopped or recreated. Finally, environment variables provide secure configuration, allowing you to keep sensitive data like API keys and database passwords out of your code, following best practices like the 12-factor app methodology used by major cloud platforms. These patterns are crucial for building reliable and secure AI applications. We've covered a lot today on orchestrating your AI platforms with Docker Compose. Let's quickly recap what we've learned. We saw how Docker Compose simplifies multi-service management, moving beyond the manual headaches of individual containers. We explored how a structured architecture ensures scalability and maintainability through distinct layers for services, networking, volumes, and configuration. You now understand how data flow and state are efficiently managed across different services, from front-end interactions to persistent database storage. And finally, we highlighted how implementing production patterns enhances reliability, security, and data integrity for your applications. By mastering these concepts, you're well equipped to build more sophisticated and manageable AI systems. For your self-assessment, consider this challenge. Design a Docker Compose setup for a personal project, thinking about its services, data persistence, and how they'd communicate. This will solidify your understanding.